Hello and welcome to this edition of Turf Core Concepts. In the last video, we used Microsoft Excel to solve some fertilizer problems. Now I'm going to go through and I'm going to show you how to actually construct the fertilizer calculator that was used in that video. The first thing I would recommend doing is pausing this video and setting your Excel up to look like mine here. Pay special attention to the yellow highlighted cells because those are going to be the input cells that feed the rest of the calculator. Now that you have your Excel set up, let's take a look at the first box for calculating, and that's going to be our pounds of nutrient per bag or pounds of nutrient in a given amount of product. So I'm going to put an example here first. We're going to pretend we have a 100-pound bag of a fertilizer that has the analysis of 20, 20, 20. And these were supposed to be empty, so we'll delete that formula there. So let's look at nitrogen first. So if you see on the slide here, this will kind of give you an idea of where I'm getting my numbers from. So the first thing I'm going to do to input a formula is equal sign. I'm going to open up a parentheses. I'm going to take my 20 pounds of nitrogen and divide it by 100 to make that 20 from the analysis a percent. And I'm going to multiply this by the weight of the bag, which we said was 100 pounds. And we get our 20 pounds. Now if we move down to phosphorus, we're going to go equal sign. I'm going to open up two parentheses because you see we're going to have an extra factor in our equation. Because in a fertilizer analysis, the second number is P2O5. So what we have to do is break that molecule into its elemental form, and we're going to add the weight of the phosphorus and the weight of the oxygen, and doing so shows us that that in one molecule of P2O5 there's 44% phosphorus. So what we do is we take the analysis of our fertilizer for P2O5 and we multiply that by 0.44, and then we divide that by 100 to get a percent, and then we multiply by the weight of our bag. And we find out how much elemental phosphorus is in 100 pounds of our 20-20-20 fertilizer. We do the same thing for potassium. Analysis multiplied, in this case, K2O is 83% potassium, so we multiply by 0.83, divide by 100 to get a percent, and then we multiply by the weight of the bag. Now that we have our formulas in these cells, we can change the weight of the bag to anything we want. So 25-pound bag changes the pounds of nitrogen per bag, pounds of phosphorus per bag, pounds of potassium per bag. Or if we want to go, we have a total of 2,000 pounds of fertilizer. We know how many pounds of nitrogen we have, we know how many pounds of phosphorus we have, and how many pounds of potassium. So I'm going to go back to my 100 for the rest of this example. So that's the first bit of this calculator. Now we're going to look at the application area of the calculator, and this is simply just using Excel to make these conversions easier for us. So let's assume we have a 5-acre area. Now to get acres to feet squared, we multiply our acre value, or let's first equal sign. We multiply our acre value by 43,560 feet squared, and then to get our unit of 1,000 feet squared, we take our feet squared value, divide by 1,000, and for simplicity and clarity, we typically use an M to indicate the 1,000 feet squared unit. Now, if you're given a problem or you have a smaller area that you want to treat and your area is given in 1,000 square feet, I have a backwards calculator back up to acre, but note that the yellow highlighted acre cell is what will feed the rest of the calculator. So this yellow cell must have a value in it for the calculator to work. These yellow highlighted cells are only to give you acre values that must then be put into this yellow highlighted cell here. So we'll add a thick outside border to that one. Alright, so let's just work backwards. 217.8 thousand square feet. If we want that to be represented in just feet squared, we multiply by 1,000. And then if we want to take this feet squared value and get it back to acre, we divide the feet squared value by 43,560 feet squared, because that's how many feet squared are in 1 acre, and we should get our 5 number because these are all the same. Now let's just say we're given a feet squared value, so we'll do the 217,800, and this it's the same thing we just did. It's this value divided by 43,560, and these should both all be 5 because we're using the same numbers. So now we can put these at 0, and that'll zero out that part of the calculator, and that's how we have some area manipulations in this calculator. Now we're going to move on to something that's a little more useful. So this pounds of product column, here is how we will get these formulas. So our desired application rate is as if we get an order or we have to apply a certain amount of nitrogen per 1,000 square feet, and we have a certain product to do it, and we know our area. So let's say, for example, I want to apply 1/10 of a pound of nitrogen per 1,000 square feet to a 5-acre area using a 20-20-20 fertilizer that comes in 100-pound bags. So what we're first going to find out is how many pounds of product will be needed to achieve that application rate. So what we have here on the slide is showing the long form way you would calculate this amount, and what we're going to use is the after the equal sign here, we're going to look for in our calculator in our givens for these values, and we're going to input them in a form that Excel will understand. So equal sign, and we're going to open up. So we're going to find our area in M units, so the 1,000 foot squared unit. So that is right here, which is calculated using this 5 acres that we inputted. So it's going to be the C14, and that is multiplied by our desired rate of nitrogen, which is this cell here, C9. And then we're going to multiply by 100 pounds of product. So where do we have our 100 pounds of product? That's up here in C2. That's it for the numerator calculation. So we're going to close our parenthesis, and we're going to divide. So we look in the denominator. I'm upsetting a cell here. So we look into the denominator, and it's a 20 pound of nitrogen is in the denominator. So we look, where can we find a 20? And it's here in pounds of nitrogen per bag or amount of fertilizer. We simply click that cell, and then when we hit enter, we are given the pounds of product that we will need. At this point, I'm going to give a little note on hard coding cells. So the way I have the calculator set up is, say you wanted a specific rate of potassium. So if I wanted 1/10 of a pound of potassium, this calculator will give you the pounds of product that are needed to deliver that rate of potassium. To get that value, and I'm just going to put in a 0.1 for phosphorus as well, we're going to need this essentially the same formula that we just created for nitrogen. However, we're going to let the we're going to let Excel autofill some things. So let's go back to our nitrogen calculation. So for any element, this area given in C14, it's going to be the same whether we have a desired rate of nitrogen, phosphorus, or potassium. So that C14 value can be hard-coded, and you do that using the F4 key. And you'll see the dollar signs go around the C and the 14. That essentially locks that cell in your formula. So no matter where you drag that formula, C14 won't change. So in the formula, another value that won't change regardless of what element we're looking for is the C2 value. So we can hard code the package amount as well. So here's what's going to happen when we go and drag this cell down. When we look at for our desired rate of phosphorus, the C14 doesn't change, the C2 doesn't change, but what does change is Excel automatically pulls down 1. So now it's inputting the desired rate of phosphorus in our equation, and then it's also inputting the pounds of phosphorus per bag in our formula. And it does the same thing for us for potassium. It allows these 3 cells to move, but locks the pounds per bag and the area because those values don't change. So that's a little bit of a shortcut, so you don't have to type this formula in a second time or third time. So I'm just going to get my colors back. Now we're going to move to how many bags do we need to apply to deliver this weight of product. And what we're going to do is we're going to take our equal sign, the number we just calculated, pounds of product needed to apply at that given rate, equals the 108.9, and we're going to divide by the pounds of product in one bag. As you can see in the slide, one bag, 100 pounds of product, and it will allow this pounds of product to cancel and leave us with bags. Hit enter, and it's saying, since we could use these to just show that there's a couple decimals here, but round to the nearest whole number to get a whole bag. You'll probably end up delivering a little less than your actual desired if you round down. So if you round up, it'll be a little different. Alright, same type of deal here with the hard code. The C2 is not going to change for phosphorus or potassium, so we could hit F4 there, enter, we get the 1. We could drag it down and it'll recalculate using the G10 value, and for potassium it's using the G11 value. So it does that automatically while still dividing by the same number because we hard coded. Alright, so that's how you can get a bags needed for a desired rate. Now we'll move on to, in our desired rate, how many pounds of nutrient will be applied. So what we're filling in the rest of this table here. So pounds of nitrogen, we're going to have our equal sign, and we're going to take our bags needed, and we're going to multiply by the pounds of nitrogen in a bag. So if you need 1 bag, you're going to multiply by 20 pounds of nitrogen per bag to get how many pounds of nitrogen will be applied. And you see, it's not a perfect 20 because this is not actually a 1. It's a 1.089, and that's what Excel will use to calculate your pounds of nitrogen. But we're telling Excel we want this number rounded to the nearest whole number. However, it will still calculate the actual value that's there. So now we'll do the same thing for potassium, which is the bags needed for our desired rate of nitrogen multiplied by the pounds of phosphorus in 1 bag. Same deal for potassium. And we'll do this, and we're just going to change down to the bags needed to deliver our desired rate of phosphorus, but we're multiplying by the same values up here. Just make sure you're going to the right cell for each. This is where the color coding kind of helps you out a little bit. All right. So now what this table is telling you is if your target is just to apply 1/10 of a pound of potassium, but you only have a 20 product to do so, you would be simultaneously applying 21 pounds of nitrogen and 11.5 pounds of phosphorus to achieve the desired rate of potassium. So that's what this table is helping you out with. Just to clean some things up, we can use these two keys to change the number of decimal places. So we can get that down to just for Excel to show us into 1 decimal place. Okay, so that's how we do this pounds of product and bags needed table. Now we'll move on to our bags used and our check. So let's just get rid of these for a second so we get all zeros, and we'll just focus on nitrogen for a second. And I'm going to change this to 0.5 pounds so that we get a bigger number here in bags needed. I'm going to take this bags needed suggestion and I'm going to enter that here. And we're going to format to essentially get these values, but we're going to make these 3 cells independent of this table. And I'll kind of show how that becomes important in a little bit. So our equal sign. So we're going to take our bags and we're going to multiply by our pounds per bag. And we do the same for each element. And now we'll use these values for our check, and it's a pound of nitrogen and we want it per area, so we'll just use our area calculation here in our pounds of nitrogen. So this check is just going to be the pounds of nitrogen we just calculated divided by the area that we're applying it to. Pounds of phosphorus divided by the area. Pounds of potassium divided by the area. And now we have our check. So this is one of the limitations or things you should know, that if we want to apply a 1/2 pound of nitrogen, our calculator is telling us 5 bags. So we go down here to our bags used and we enter our 5 pounds, or I'm sorry, we enter our 5 bags, and our check tells us we're only applying 0.46 pounds of nitrogen per 1,000 square feet. So let's try if we applied 5.5 pound bags. Now our check shows us that we're applying 0.51 pounds of nitrogen. So that kind of lets us know that if we're going to make an order for these 100-pound bags, we need to buy 6 bags, not 5, or we're going to be applying a little bit less than our desired rate. So that's a little bit of a limitation. And you could also go here and see that it's a 4-5. So if you rounded this to 1 decimal, this will be a 5-5, but you could add your check as well. So it's kind of however you want to do it that makes the most sense to you. You could just have a couple decimals here and you do your rounding, or you can use this bags check. But having this formula, these two tables is going to be useful for this right here that we're going to talk through. So let's zero out the entire calculator. We'll add zeros to everything. And we're going to kind of work backwards and show another capability. So if we don't have a desired application rate and we want to find out we want to find out the rate that we applied nitrogen at, and we say we have 50-pound bags of a 2205 fertilizer, and we went out and applied it to our primary rough or something. So we have an approximate acreage of 36 acres for that, and we used a total of 119 bags. We can, using these check functions, we see that we applied 0.83 pounds of nitrogen per 1,000 square feet. And the reason we had these tables independent of our pounds of product is for this very reason, so we could work backwards. If we send someone out to apply a fertilizer to a known area, they use a certain amount of bags, and we know the analysis and the weight per bag, we can use this check function to get our pounds of nitrogen per application area. So that's another use of the calculator there. So I would recommend, before saving your calculator, to zero everything out, so that you're basically just saving a blank template to be used. And I hope you have success using this calculator.